Hey everybody, here is our last lesson from Unit 5. It says Unit 5, Lesson 5, Solving Radical Equations. We've covered the rest of simplifying exponents, simplifying radicals, looking at radical graphs and radical transformations previously in this unit. This one here is going to be covering our last section, which are basically just normal equations, but instead of just having a plain old 4x minus 1 equals -5, now we're just going to throw a radical over the top. Up at the top here, it basically just says what I just said. This last line, though, does say this topic should feel familiar, as it will follow similar steps to how we solve multi-step equations. Just in case you do need to see that information again, that is on page 3 of our journal at the very front in Unit 0. Okay, we're going to go a little bit out of order. We're going to do in order of how hard they are. So we're actually going to skip our non-numbered example. We'll go back to that one. We're going to start with number 1. I'm just going to follow the steps here. Number 1, step 1 says simplify any terms not inside a radical to one side. By the inside of the radical, we really mean like under the radical. There is nothing over on this side of the equal sign. Remember, when we say sides, we mean of the equal sign. That isn't in the radical. We only have one thing that's not in the radical. It's over here. This number is already on one side, so we're good. Going to step 2. Step 2 says raise both sides of the equation to the power of your index, which is the number of your root. I'm going to have us draw that over here. That's our radical. Here is the index right there. Remember, if there's not an index, the index is 2. That's why we always used to call it a square root sign. Now here on number 1, we're going to raise both sides to the power of 3 because 3 is our index. You can see that right there. And the reason we're doing that is because it will cancel out this side here to just give us 4x minus 1, because taking the cube root and then cubing it gives you whatever's just on the inside. And then on the right side, we have -5 cubed. That would be -125. I just did that in my head, but you can use a calculator. Step 3, if you have only x terms, follow the equation rules to solve for x. If you have x squared terms, move all to one side so you can factor to solve for x. Looking at ours, we just have an x term, so we just use normal equation rules for this. Normal equation rules say that we're going to move everything away from our variable, and we're going to start with any constant terms and then get rid of any coefficients. A constant term just means a number that is not attached to a variable. So I got one right there. I add it because that's the opposite of subtracting. And then I have 4x here. That's being multiplied. So I would just divide because that's the opposite of multiply. Sorry, inverse of multiply. And then let's type this in the calculator. It tells me -31 when I do that. And then our last step, step 4, says check for extraneous solutions by plugging answers back into the original problem to ensure your answers are true. This actually only applies to even index numbers. We don't have to do that for our question. We only have to do it if we have a squared or a fourth root. I'll put that over here. Only for even index number. There. Ooh, that arrow looks like I'm talking. This is not related to this question. Just the step 4. And there we go. So go ahead and try that. We'll do the same thing. If you look at the next page over here for number 4, we'll do number 4 first because that one is the closest related to the one we just did. So go ahead and try number 4 and then come back when you're ready. Go ahead and check your answer. You should have x equals 2. Then I'm going to show you on this one how we would check our answer. So check answer. And this is step 4. We are checking this one because it is a square root, which is an even index number. This just means that we don't exist everywhere along the domain. There are numbers we could plug in here that would give us undefined, or in this case, it would actually give us an imaginary number because we can't divide, or not divide, sorry, take the square root of a negative number. So I'm just going to plug in 2 wherever I have x. And it looks like that. And then we'll just type this entire part in the calculator. I might still have it saved from earlier. Let's see. Perfect, I do. It's right here. It says 0 right there. So it's 0 equals 0. That is a true statement. 0 does equal 0. So that means this question is an answer, or the correct answer. That is not a restricted value. And there we go. Perfect. Let's go back to the first page. We'll now try number 2 together. This is the same concept. We just have a few extra things to move around for step 1. So I just want to go over this one together. Remember our first step here, step 1 says simplify any terms not inside the radical to one side. Here's the radical. So I have this on the outside, that on the outside, and that on the outside. I want all 3 of these numbers to be in one spot. So I'm going to go ahead and move those. I'll move my constant term first, just like I always do. And that gets me here. There we go. Then I'll get rid of that 5 that's being multiplied, so I would divide, just like I would with the normal coefficient. And that is step 1. Step 2 says raise both sides of the equation to the power of your index. Remember, if you don't see a power, it is 2. So you would square this. These would cancel. I would just get 3x plus 46 because squaring a cube or a square root would cancel it. And then on the right side, we have 1 squared is just 1. So just to make sure we see what's happening, you do not have to label these if you don't want to. I'm just showing you. This is step 2. And then step 3 says if you only have x terms, which we do, follow equation rules to solve for x. We just do what we would normally do to solve for an equation. I'll do the opposite of what's happening. So I subtracted 46 because it was adding. That's the opposite, or inverse, sorry. I was multiplying by 3, so I divided by 3. And that gave me negative 15. This one is a squared. So you would check our answer to make sure it's not an extraneous solution. Do that by we're just going to write my original equation with x plugged in. There we go. And then here, I'm just going to type this entire thing into the calculator, and it tells me 3. 3 does equal 3, so this is true. Good. Go back to the next page. Go ahead and try number 3. And then unpause when you're ready to check it. Here is number 3 for you to go ahead and check it. It was really similar to number 4 because the second half, after you got through step 1, step 2, 3, and 4 were actually the same. We should have gotten 2. So the next one we're going to try is number 5. Then you can try number 6. These are a little different. If you'll notice in step 1, remember we normally say move everything that's not in a radical. If you look on the left side and on the right side, everything's in a radical. So the only thing you can do is skip to step 2, which is to raise both sides of your equation to the power of your index. So if I have an index of 3, I would raise both sides to the power of 3, or cube them. That would cancel out our cube roots, and we would end up with 5x minus 6 on the left, and x plus 4 on the right. From here, step 3 says, if you only have an x term, just solve it like a normal equation. That's what we'll do. There we go. And then I'll divide by 4. The answer is 10 over 4, but the simplified answer would be 5 halves. And then for this one, we would not do step number 4, which is check for a restricted value or an extraneous solution, because these are cubic, and you can take the cube of a negative number, so they're going to have no restrictions at all. Good. Go ahead and see if you can pause and try number 6. And then come back when you're ready. Here is number 6. You should have gotten x equals -1. Go ahead and check your steps there. And then over here on the right, I did check my answer. I am not going to require you to show this work on your practice page. Just know that sometimes you will have an extraneous solution. You need to be able to identify when that happens. Let's look at our original question over here. This is the unnumbered example. And this one you'll notice is going to give us 2 answers because we're going to have to factor. Let's go ahead and try this one. Step 1, simplify any terms not inside the radical to one side of the equal. As you can see here, I have just a radical on this side and then the non-radical stuff on this side. So we're already off to a good start. Here is step 1 done. Step 2, raise both sides of the equation to the power of your index. We have an invisible 2 here, so we're going to square both sides. That gets us to here. This is the end of step 2. Step 3, if you have x squared terms, move all to one side so you can factor to solve for x. We're not 100% sure we have an x squared. It looks like we will here, but to know for sure, we do need to multiply that out. So let's go ahead and do that first. I'm just going to do normal double distribution. You were also might have been taught that it was called FOIL in the past, but we've always used the phrase double distribution in here. We learned this, well, we reviewed this. It's from 9th grade. Actually, it might be from 8th grade. I'm not 100% sure on that. We reviewed this in Unit 2, if you want to go back and look at your notes. Here, I just remultiplied x plus 5 times x plus 5. I'm just going to simplify it down, combine my like terms there. And that gets me to here. And then the rest of step 3 says get everything to one side so you can factor. We have 2 terms over here and 3 terms over here. So it'd make more sense to move these over here because it's less work than these 3 over here. I'm just going to do the inverse operations here. So if you have a positive 3x, we will subtract 3x. That'll cancel. I'll do it from right here because those are like terms. Both have an x. Then I have a positive 13. I'm just going to subtract 13 because that would cancel. Then I'll put it over here under the other constant term. And I end up with a 0 on the left side. X squared plus 10 minus 3 is 7. Plus 25 minus 13 is 12. Now I will factor. I have a trinomial. There's 3 terms here, so I'm going to label them A, B, C. We'll just make a multiply add chart. Multiply to A times C, 1 times 12. Add to B, which is 7. So we want a pair of numbers that multiplies to make 12 and adds to make 7. That would be 3 and 4. And then remember, I can just put it straight into my parentheses as long as I have a 1x squared, which I do. Positive 3 and positive 4. Now from here, I would just solve each of my factors for x. That's how I got -3. And then this one, that's how I got -4. And there we go. So these are the 2 answers. We want to see if either of them is extraneous. So all we're going to do for step 4 is plug them back into the original equation. But here's our original equation. So it is the square root of 3x plus 13 equals x plus 5. I'm just going to write it in here so I can get ready for checking both my answers. And then I'll just plug in the number that I got for each one. Okay, I got a -4 and a -3. Then what I'll do is just type each side into the calculator like that. On this one, I'll get 1 equals 1, which is true. So -4 is a solution. And then we'll do the same thing over here. This will give me 2 and 2. 2 does equal 2. So -3 is also an answer. And that's how you do the long one. Coming over here, we have two examples to try that out with. This one is easier, but is going to seem harder. So we'll do this one first together, then you can try number 8. Looking at number 7, our normal goal is to move everything to one side that's not inside the radical. If you were to divide this by 2, that would give us x over 2, and then eventually the whole thing squared. It would be easier if we just squared both sides first because we don't have anything for it to divide by. That's not an x. So if I do that, this would give me 2 squared, and then square root of x squared equals x squared. These would cancel. 2 times 2 is 4, so this is really 4x. Oh, sorry, equals x squared. Then we want to get everything to one side. Keep trying to write that 4. X squared minus 4x. And now I want to factor. I don't have a trinomial, so I cannot do a multiply add chart, but I could take out a greatest common factor of x. Like that. And then I'll set each of the factors equal to 0, just like I did in the last one. And that gets us to here. Our answer is 0 and 4. Okay, go ahead and try number 8. Number 8 is much more similar. It's not dissimilar from this, but it's much more similar to this one. So if you want to look over the one we did together, this is way more the same as you'll see for number 8. So go ahead and pause, try number 8, and then come back when you're ready. Okay, go ahead and check number 8. Here it is. You should have gotten -4 and -5. Okay, just a reminder, when we have a square root or a fourth root, just that it's not an odd root, we could plug it back into our original equation to look for extraneous solutions. If you decide to do that, obviously, you will be able to tell if they're both true or if only one is true. I'm just going to tell you they are both true on here because I don't feel like going through it, but that's how you do it again. Perfect. Hope this helps. Have a great day. Bye.